This tutorial shows how to create a plane from a set of points and calculate flatness of the plane and the angle of the plane relative to its parallel Cartesian coordinate plane. Click Setup to get started, then Setup Editor. Click Computer Options and then Geometric Objects. A plane is created from a set of points. Therefore, we must first create the point set and the points that will be used to generate the plane. Click the New button to create a new point set. Enter a desired name for the point set. In this example, we will use surface J as the name of the plane. It is good practice to incorporate the plane's name in the point set name. So enter surface J points for the point set name. The surface J plane will be generated from 8 points. Create 8 points for the plane. Set the enabled property of each point to assign the point to the currently selected point set. In this case, the surface J points set. Enter appropriate point names for each of the 8 points. So here we're just going to name them J1, J2, J3, J4, etc. Now the points need to be defined. The x and y values are usually constants and should be defined on the gauge drawing. The locations will be defined relative to the fixture coordinate origin. The actual location of the origin is not important as long as each x and y value is defined relative to the same origin. The z value will be obtained from a connected sensor located at the xy position in the fixture. Enter the x and y constant values. They should be in the same units as the measurements. That is, if the measurements will be defined in millimeter units, the x and y distances should be entered in millimeters. Set the z value to the scale fields that will be receiving the sensor data. We will assume the first 8 scale fields have been designated for these sensors. Right-click the z cell and select the proper scaled field for each point. And if you are using Orbit digital probes, this is where they would be entered. The points required to generate the plane are now completely defined. Click the Objects tab so that the plane can be created. Click the New button to create a new plane. Enter the plane name, in this case, surface J. Finalize the plane definition by selecting the point set containing the points for this plane. Optionally, a comment can also be entered describing the plane use. Geometric objects have global scope. They are available for use with any part program and exist even before the part programs are created. Now that the plane has been created, it can be viewed. Return to Gauging and then select Visualizations from the Data Collect menu. Scroll down to select the Surface J plane. The plane and each of the points defining it can be viewed. The plane is not updated live. It can be updated using the current scaled field values by clicking the Update button. Using the graph slide bars allows the viewed direction to be modified. If the plane is observed from one of its edges, it can be seen that some points are above the plane and some points are below the plane. This is to be expected. Data Collect uses a least squares best fit calculation to find the plane that best fits the data points. The visualization screen shows the resulting equation of the plane and the resulting flatness. The 2 points shown in red on the plot are the 2 points furthest from the plane and determine the flatness value. The plane has been created and viewed to verify its correctness. Now it can be used in an inspection sequence. Exit the visualization screen and return to the setup editor. Click Part Options and then Sequence to display the inspection sequence editor. Add a gauge to the sequence and a step to the gauge. Add a measurement to the step and select the Flatness measurement template. Set parameter 1 of the Flatness template to Surface J plane. A measurement reporting flatness has now been added to the sequence. Return to Gauging to observe the value. The flatness value is updated live, just like all other measurement values. Changes in any sensor value used to define the points of the plane will affect the final flatness value. Surface J was defined in the XY plane. This means that if all Z sensor values are 0, surface J will be parallel to the XY plane. If a part is located on the XY plane with surface J being a second parallel surface, it might be useful to determine the angle between surface J and the locating surface. This can easily be added. Click Setup and then Setup Editor. Select the M1 flatness measurement and enter a more meaningful name. Select the inspection node and add a second measurement. Select the plane-to-plane angle template and then set its parameters to surface J and XY plane. This will return the angle between surface J and the locating surface. Enter an appropriate name for the new measurement. Return to gauging to observe both the surface J flatness and angle of surface J to the XY plane. Both measurement values update as the sensor inputs change. That concludes this tutorial. Again, if you require other training videos, please go to the Solartron YouTube channel. Thank you and have a good day.